Hello, welcome to Pragim Technologies. I am Venkat. This is part 36 of SQL Server. In this session, we'll learn about the different types of indexes that are available in SQL Server, what are clustered and non-clustered indexes, and the difference between them. Before continuing with the session, I strongly recommend to watch part 35 of this video series. The following are the different types of indexes that are available in SQL Server: clustered, non-clustered, unique, filtered, XML, full text, spatial, column store, index with included columns, index on computed columns. In this session, we'll be talking about clustered and non-clustered indexes and the difference between them. So what's a clustered index? A clustered index determines the physical order of data in a table. For this reason, a table can have only one clustered index. We have a create table statement here where we are creating TBL employees table. And if you look at this closely, the ID column is marked as a primary key column. A primary key constraint will automatically create a clustered index on that column. Here ID is marked as a primary key column. So when I create this table using this create table statement, it's going to create a clustered index automatically on this ID column for this table. Let's look at this in action. I have the same create table statement here. Let's execute this. Command completed successfully. Now let's check, if it has created a clustered index on this ID automatically. And how do we check that? There are two ways. One way is to basically use this sp_help index system stored procedure, passing it the name of the table. Okay, so it shows that we have a clustered index on this ID column. Okay, we did not create this explicitly. It got automatically created because a primary key constraint will automatically create a clustered index on that column if the table doesn't have any clustered index. Okay, and if you look at this, it says it's a unique clustered index, clustered unique index. Okay, so what is a unique index? We'll be talking about them in the next session, but at this point understand that this unique index is basically used by SQL Server to enforce the uniqueness of the primary key. Okay, we will be talking about unique indexes in detail in the next session. Alright, what is the other way of checking the indexes on this table? One is to use the sp_help index system stored procedure. The other one is basically to use the Object Explorer. Within the Object Explorer, expand the TBL employees table, so TBL employee table, and expand the indexes folder. You should see the index that has just been created. Alright, okay, so now we just have created this table TBL employee. Now let's insert some data into that. Okay, and look at this, I have some insert statements here, and if you look at this, we are inserting values for ID, name, salary, gender, and city here. And if you look at this data closely, the values for the ID column are not in sequential order. I am intentionally inserting them in a non-sequential order. Okay, so we told that a cluster index determines the physical order of data in a table, and in this table on the ID column we have a cluster index. So even if you insert data in this order, first the third record, then the first record, then the fourth record, when I say select star from TBL employee, the data should have been automatically arranged in this order. So when I insert 3, it inserts it in the first location, and when I insert the record with ID is equal to 1, it should push number 3 down and insert 1 before that. And along the same lines, when I insert 4, it should come after 3, and when I insert 5, it should come after 5, and when I insert 2, it should automatically insert that between records 1 and 3. So it should rearrange the data based on the ID, based on the value of the ID column. Okay, let's see if that happens. Okay, so now if you select from the table, we don't have any rows. So let's insert the data, and notice that the values for the ID column are not in sequential order. Execute. The data is inserted now, but look at this. When I say select star from TBL employee, the data is arranged in an ascending order of this ID column. So the clustered index determines how the data is stored in this table. So a clustered index is analogous to a telephone directory where the data is arranged by the last name. So in the telephone directory the data is arranged by last name. Similarly, in a table the data is arranged by the clustered index key. Okay, and we just learned that a table can have only one clustered index. But however, the index, the one clustered index, that one clustered index can contain multiple columns. And if a clustered index contain multiple columns within that, we call that kind of an index as a composite index. Since it's a clustered index, we can call it as composite clustered index. Similarly, a non-clustered index also can have multiple columns within that, in which case we call it a composite non-clustered index. Okay, now in the telephone directory, you can consider the telephone directory just like a composite index, because basically the numbers are organized by last name first, and then if there are similar last names for people or organizations, then the data is arranged according to their first names. Okay, so in a similar fashion, we can create a composite clustered index on this employee table for gender and salary. Okay, so basically what happens is when we create this index, now if you look at the way we have the data, it's arranged in the order of this ID column, because currently we have a clustered index on the ID column. Okay, but instead of that, I want to create a clustered index on the gender and salary columns together, which means I want to sort the data first by gender and then by salary. The data should be arranged in that order in this table. So obviously when we try to do that, what happens to the order of the IDs? Obviously that will be messed up. So at any given point of time, you can only arrange data in a certain way. That is the reason why you can have only one clustered index per table. Okay, so now let's try to create a clustered index on the gender and salary. But remember, there is already a clustered index on the ID column. So obviously when we try to create this clustered index on this table, we should get an error stating that you cannot create more than one clustered index on the table TBL employee. Drop the existing clustered index before creating another one. Okay, so obviously we'll have to drop that. And to drop an index on a table, there are again two ways. One is to use the query, so drop index and the index name. But since an index is on a table, you'll have to specify the table name as well when you're dropping an index. So TBL employee dot the index name. So let's copy that. When we execute this now, look at this, we get again an error. An explicit drop index is not allowed on this index because it is being used for primary key constraint enforcement. Okay, we'll talk about how a unique clustered index is used to enforce primary key constraint. We'll talk about that in the next session when we talk about unique and non-unique indexes. Okay, but to safely delete this index, what you can do is go to the Object Explorer, expand the indexes folder, right click on the index and select delete and click OK. That should delete the index. Okay, so we have deleted the clustered index on the ID column. Now let's try to create the clustered index on the gender and salary columns. Okay, so basically this is a composite clustered index because your index is containing more than one column now. Okay, keep in mind you can only have one clustered index on a table. It's not possible to have more than one clustered index, but it is possible for that one clustered index to have more than one column within that as index keys. So here the clustered index that I'm going to create now is going to have two columns as the index keys, gender and salary. Gender will be arranged in descending order first, and then salary within that gender in ascending order. So execute. Now let's select the data from the employees table. Before we created this index, it was arranged in the ascending order of the ID column, but since now we have created a clustered index on gender and salary columns, now the data is first arranged in this table in the descending order of gender first, and then within the gender it's then arranged in ascending order of the salaries. Okay, so that's clustered indexes. Okay, so a table can have only one clustered index, and clustered index determines the order in which the data gets stored in that table. Okay, and to create a clustered index, it's pretty simple. Create clustered index, the name of the index, and we have spoken about the naming conventions to use when we are creating an index on a table, on table, and for which columns. And if I have to create a non-clustered index, so how do we create that? We say create non-clustered index. The only difference is instead of saying clustered, you specify non-clustered. So here if you look at the example, I am creating a non-clustered index on the name column for TBL employee table. Okay, now when we spoke about clustered indexes, we understood that the data in the table is arranged based on the clustered index column. Okay, now when you create a non-clustered index, a non-clustered index is analogous to an index in a textbook. Okay, so if you look at the index in a textbook, the index is stored in a separate place and the data is stored in a separate place. For example, at the beginning of the book you have the index, chapter index. Now if I ask you to go to a specific chapter, you will first check the index. Okay, chapter 5 is on page number 400. So you will go to page 400. So the index is stored separately and the data itself is stored separately. So the index in a book is a little different to an index in a telephone directory or a dictionary. Okay, so in a telephone directory or a dictionary, the data is arranged in the alphabetical order. Basically the data itself is arranged. You don't have a separate index pages and separate data pages, but in a book you have separate index pages and separate data pages. So similarly, a non-clustered index is analogous to a book index. Okay, the index itself is stored separately here. For example, since we have created a non-clustered index on the name column, the names are arranged in the ascending order here, and then each name have row address. For example, if I write a query select star from TBL employee where name is equal to Todd, what is going to happen? It's going to come here. Okay, Todd is here because T, when you compare with JPS, it will be present in the end, so it comes here. Okay, Todd is here, the row address is here. It goes to the table based on the row address and then directly fetch that record. So since the non-clustered index is stored separately from the actual table, a table can actually have more than one non-clustered index. Okay, just like how a book can have an index by chapters at the beginning and maybe another index by common terms at the end of the book. Okay, so the indexes that we see in a book, we can have as many indexes as we want of that kind. Okay, so the same is applicable for non-clustered indexes. I can create one index on name column, another index on city column. So there is no really restriction on how many indexes, on how many non-clustered indexes you can have. Okay, but clustered indexes only one. Why? Because you can only arrange data in one way. If you try to arrange by another column, obviously you will lose that ordering on the first column. For that reason, you can only have one clustered index on a table. Okay, and in a non-clustered index, the data itself is arranged based on that index key, either in ascending or descending order, and you can specify that when you're creating the index. Okay, but this one will not in any way, the non-clustered index will not in any way influence the way in which data gets stored in the table itself. That is determined by the clustered index key. And if you don't have a clustered index on the table, then the data is not guaranteed to be ordered in any specific way. Okay, finally we'll look at the differences between a clustered and a non-clustered index. Okay, and this is a very common interview question that's asked these days. Okay, and from whatever we have learned until now, you can have only one clustered index per table, whereas you can have more than one non-clustered index, and there is a logical reasoning behind that, and I believe you understand that. Clustered index is obviously faster than non-clustered index because the clustered index has to refer back to the table if the selected column is not present in the index. Okay, what do we mean by that? For example, this is a non-clustered index. Now when I ask, select ID, salary, gender from TBL employee where name is equal to Sarah, what will you do? You first check the index. Okay, Sarah's record is here. This is the row address. And if I want the ID and salary columns, I don't have those columns in this index. So I will have to refer the table back. Okay, so obviously there is this one extra lookup involved if it's a non-clustered index. But on the other hand, if it's a clustered index, then all the columns are present in the table itself, and the data itself in the table is arranged based on that clustered index, so you don't have that extra lookup. That's why clustered indexes are slightly faster than non-clustered indexes. Clustered index determines the storage order of rows in the table and hence doesn't require additional disk space, obviously. But whereas non-clustered indexes, if you look at here, non-clustered indexes are stored separately. Okay, and you're duplicating this name. Let's say, for example, I have million records here. You will have million records in the index as well. And since non-clustered indexes are stored separately from the table itself, you require extra disk storage space. But for clustered index, it's not the case because its clustered index just determines the order of data in the table itself. You don't require additional disk storage space. So these are the three differences between a clustered and a non-clustered index. On this slide, you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.